Hello, my name is Philip, and this is my presentation for the second lab. So, the purpose of this lab was to be an extension of the first lab by creating a line of charge to closely estimate the forces of charges and on the tape as to the point charge assumption used in lab 1. So, the fundamentals in this lab is that we're using superposition to simulate charges on the tape as a line of multiple charges and adding them together. Um, so this uses E net equals the sum of the electric fields, where we get the charge and the electric field of a single charge, and then we add them up, accounting for the different directions of the vectors and the magnitude to get the final electric field. We also use Newton's second law, where F equals ma, and Coulomb's law, F equals QE, charge times electric field, to calculate the charge and the force of each piece of tape. For the results, the magnitude of the charge on one piece of tape was 7 times 68 times 10 to the minus 9 coulombs. The magnitude of the electric field was 1.4641 times 10 to the minus 3 newtons. And as a side note, this results are supposed to be more accurate than Lab 1, but there was an error in Lab 1 that I was able to catch, which might not lead to an accurate comparison for the two. Assumptions for this was that each U-tape had the same amount of charge that were evenly distributed across the length of the tape, and there were it was assumed that there were no other forces affecting the tape. The systems of this um, experiment was tape B, and the surrounding was tape A. For the experimental model, the initial condition was two pieces of neutral tape attached onto the table. Um, and then two pieces of U tape, tape A and tape B, were charged by sticking them to a tape on the desk and swiftly pulling it off. U tapes were both positive because it was attracted to the negative pen. Tape B is bridged between the two tall objects, and tape A is held close to tape B from the other side. Tape A approaches tape B until tape B moved up from the original position shown by the model, and the distance between tape A and tape B is measured to find the electrical force. So here's a new charge model. As you can see, this time the tape is represented by a line of multiple charges. For our code, um, the initial parts of the code are same, like UFPES, G, mass, and length of the tapes. But the change starts with the bottom right of the code, where we start with the line charge assumption instead of the point charge assumption. This code defines the basics of the line charge. And the middle of the code actually creates the objects for the line charge for the top tape and the bottom tape. For this experiment, divided up the tape into 100 finite pieces of charges, represented by n equals 100. And for here, the code creates like instantiation for the electric fields, and at the bottom, we actually get the electric fields and add them up to find the electric net field, and then we multiply that with the charge to get the electric force. And here we get the final numbers for the magnitude of the electric force and the gravitational force, and this also creates the arrow for the model. So finally, we got the magnitude of the electric force of 1.4641 times e to the minus 3 newtons, and the gravitational force had a magnitude of 1.962 times minus 3 newtons. And the final charge was 7.68 times 10 to the minus 9 coulombs. So the experimental data shows that lab 2 had these numbers as shown before, and this compares to the lab 1 data where we got 1.962 times minus 3 newtons for both forces and 7 um, times 10 to the minus 9 coulombs for the charge on one piece of tape. So the results are supposed to be more accurate than lab 1 results because we divided the tape into multiple pieces. The electrical force is slightly different from the gravitational force. As mentioned before, there was an error in lab 1 in the process of getting the gravitational force, which might have led to this different. Um, the possible errors other than that is that the charge could have moved around while being handled, and charges were not distributed evenly across the tape. For discussion, what if we modeled this tape as a single charge? This is pretty much lab 1. So dividing the number of charges we got from lab 2 divided by the number of charge, or the amount of charge in lab 1, we get the number 1.097. So So lab 2 has this many more amount of charges than lab 1, so this should be more accurate. So these estimates do differ because the first lab was oversimplified. It was only a single charge, but this lab closely estimates the number of charges because it accounts for the fact that the tape has multiple distributed charges. Thank you for watching.